Everyone, this is Yu Huangchen and
Jianan Li.
yeah, we're doing a presentation for our electrical engineering 3 class.
Yes.
And our project is
the wireless control. And our project has two parts. The first part is we control the model car. This is a normal RC radio controlled car, and this is a Wii controller, which is normally used for the game station. But we are in the map so that we can use this controller to control this model car. And first, let's see how a normal model car works. It has a battery, and the battery gives power to the electric speed control, and the electric speed control gives the signal to the motor so that it controls the car to move forward or backward. And we have another servo motor which controls the direction of the front wheel so that you can move leftward and right or right. And to get the input from the human, we have a RC controller and an RC receiver. Like this, the player uses the RC controller to control the forward or backward direction and leftward or rightward. And these signals will be transmitted to the RC receiver, which in turn controls the electric speed control or the servo motor. So what we are doing is to replace the RC controller and the RC receiver with our own control system. And to do this, we have a Wii receiver, which gets power from the Arduino, and the signal for the Wii receiver comes from the Wii controller, and we decode the inputs from there to the Arduino. And the Arduino is powered by the battery eliminator circuit from the ESC, and it interprets the signals from the Wii receiver and in turn gives the output to the ESC and the servo motor, so we can use the Wii controller to control the model car. Okay, and this is the second part.
Alright, here's the second part, which is a Bluetooth controlled motorized camera slider. As you can see, it's in action. Alright, so let me introduce the parts I used for this part, the second part of the project. First, there is a camera slider, just a normal one. I bought from Amazon or whatever. And second, there is a Arduino, which is used as the microcontroller of the whole project. And the third part is a stepper motor, which can drive the pulley and the timing belt so that the slider can move with the motor. And the fourth part is a motor driver, which is a Adafruit motor shout, I guess. It's much easier to use it to control the stepper than like anything else. And we have a Bluetooth module, which we use to connect to our iOS device. And we can control the motor slider with an iOS app via this Bluetooth module. And we have a battery pack. It has 8 AA batteries in it. And we have the timing belt and pulleys. And we also have some 3D printed parts, which is printed from UCLA Library, or the 3D4E, the 3D Printing Club. It's for free. And the last one is the iOS app we created for this project. Alright, so for this project, the hardware are actually there. So what we basically did was to solder everything together and assemble the parts we designed and assemble all the motors, pulley together. And so the most work for this project is for the coding part. So what we did for coding, like there's 3 parts. The first is on Arduino. The second is on the iOS, like iPhone or iPad, and the third part is like the communication in between. So I will talk a little about all of them. So first, for the Arduino, we have to control the stepper motor. To control it, we have a library from Arduino, from the company, and from Adafruit as well. But like there's like several modes you can choose from. There's 4 different drive modes, like double step, single step, and I guess interleave mode and micro step mode, and each of them have different characteristics. Like they have different torque, they make different noise, they move differently, and yeah, it changes the speed and how the slider behaves. And the second part is to have a happy user, which means our program should be user friendly. For example, if our slider moves, we should call the step function in the Arduino, which is step function, and the function itself doesn't return after it steps all the steps you specified. So imagine a user was like hit a button and ask the slider to step all the way to the back, and it may take like 2 minutes. But what if the user like change his mind and say, "Oh, I need to reset the slider to the original location," then he might have to wait for like 2 minutes before he can do reset. That's because the step function doesn't return after it finish the whole process. So what we did was we have to consider that what if the user pressed the reset function of the reset button, then we slice the whole process into very small pieces. So whenever the user presses the reset button, it can like respond quickly. And the third was the timing requirements. Because we have a time-lapse mode for our slider, so the timing should be precise. Like during each interval it moves. So at first we use a delay function, which will like delay for a second after each move. But like later we found out that if we use delay, then it doesn't account for the time that it actually steps. So it will like the interval will become like more than 1 second because we delayed for 1 second, and it still takes time to move a bit. So there's like a timing requirements we have to satisfy. So basically what we do was to create a separate, it's like a clock that has a function called micros, which gives you the microsecond time from the start of the program. So we use that to ensure that each interval is exactly 1 second or 2 seconds or whatever you specified. Alright, for the iOS part, first we were using a Swift programming language, which is like newly introduced by Apple like a few years ago. We learned that from scratch. And for the happy user part, we were like trying to design a simple to use, a user-friendly interface. For example, the iOS app itself connects to the Bluetooth slider automatically, so you don't have to press button which one to connect, which device to connect. It will just do it for you. And the last part is the core Bluetooth, which is I think a library or framework that Apple provides us to use the Bluetooth as a service. We download some code from the internet, the low-level Bluetooth stuff, and in between is like we have to send a command from the iOS to the Bluetooth slider. So the Bluetooth is using the UART connection, which will send 8-bit command at a time. So we have to account for the intervals or the speed we want to use, and like how many frames we want to take, and and how many interval so how long the interval should be, how many frames we want to take, and how fast the slider should move. So there's a lot of things to do, but we only have 8-bit, which is like 256 different commands, and we have to. So what we did was we used 4-bit as the speed or frame selection. So there's 16 different speeds or frame numbers you can choose from. And we have 3-bit for interval selection, so we have 8, I guess it's 8 different interval you can choose from, and 1-bit for orientation, whether we want to move forward or backwards. And for reset, we set it to all, I think it's all 1, so it's hexadecimal F and F. That's for the reset function. So whenever it resets, it will just go back to the original location, and we don't have extra sensors for where the motor is, because the stepper motor, like it counts the steps every time it moves, so it doesn't need anything else, any other sensors to sense its location. And that's it.
Yeah. Okay. So to see a live demo, you can check out our demo video link below. And like about the future work path, this is gonna be interesting. Like what we did was we transferred the wireless control technology to our electric skateboard, and like for a simple control we can use the Wii controller, but if we want to control the electric skateboard in the more complex way, we can do the Bluetooth part, because that can transfer more data and more precise control, and probably even some map data. Yeah, but like due to the logistics of this class, we cannot show our electric skateboard to you. But yeah, so this is our wireless control project.
Alright, thank you very much.
Thank you.